Assalamualaikum and hi. Today I would like to present two tasks which are design a fuzzy membership function with rule-based that can gain almost the same performance as the PID controller, which are 3x3 and 5x5. So this is our group members, which is first is me, and Nadira binti Kamara Arifin. My metric number is CE19049, and the other one is Shamil Bakri bin Ibrahim, and his metric number is CE190170. So what is fuzziness? It finds applications in various domains where imprecision, uncertainty, or ambiguity are present by control system, which it is to handle uncertain or imprecise inputs and provide adaptive control. Then it is a pattern recognition to allow more flexible decision boundaries and can handle overlapping or ambiguous data. Third is a decision making, which it is allows incorporation of imprecise or incomplete data and provides a more human-friendly approach to decision making. And last is expert system. Fuzzy is an expert system which it enables reasoning with imprecise or uncertain knowledge. So fuzzification is the process of converting crisp or precise input values into fuzzy values or fuzzy cells. The purpose of fuzzification is to capture the gradual transition between membership and non-membership of elements to different linguistic terms of fuzzy sets. So for the rule-based 3x3 is, the example is rule 1. If error is low, then control signal is low. Rule 2, if error is low, then control signal is medium. Rule 3, if error is low, then control signal is high, and so on until the rule 9. If error is high, then control signal is high. So the specific shapes and ranges of the membership functions will depend on the characteristic of the system and the control requirements. Designing an effective fuzzy logic controller with good performance requires careful consideration of the system dynamics, tuning of membership function parameters, and rule-based optimization. As for rule-based 5x5, it's very low. First is very low. A triangular membership function centered around the lower range of the control signal. For low, triangular membership function with a wider range than very low. Medium, triangular or trapezoidal membership function centered around the desired control signal range. High, a triangular membership function with a wider range than medium. Last is very high triangular membership function centered around the upper range of the control signal. For rule-based 5x5, it will have 25 rules in total, where each rule combines one linguistic term from the error variable and one linguistic term from the control signal variable. As for defuzzification 3x3, it first is to identify the linguistic terms. As the example, if the output variable is control signal, the linguistic terms could be low, medium, and high. Second is the membership functions. This function describes the degrees of membership for the output variable. Third is rule evaluation. It applies the fuzzy logic rules, combining the fuzzy inputs, which is fuzzified crisp values using the rule base. This results in fuzzy output associated with the linguistic terms. And last is centroid defuzzification. One commonly used method for defuzzification is centroid defuzzification. It calculates the center of gravity of the combined fuzzy outputs. The centroid represents the crisp output value. But the other method is bisector of array method. It's the same for 5x5. First is to identify the linguistic terms. As the example, if the output variable is control signal, you may have terms like very low, low, medium, high, and very high. Second is membership functions. It describes the degrees of membership for the output variable. Third is rule evaluation. It applies the fuzzy logic rules based on the 5x5 rule base, combining the fuzzy inputs using the appropriate linguistic terms and rule firing strengths. Last is centroid defuzzification. It uses centroid defuzzification to calculate the trip's output value based on the combined fuzzy outputs. For the side note, it's important to note that there are alternative methods for defuzzification, such as the maximum membership or height defuzzification. The specific defuzzification method employed may depend on the requirements of the application and the nature of the fuzzy inference system. Defuzzification is a critical step in converting fuzzy outputs into crisp values that can be used for decision-making or control purposes. The particular process employed depends on the linguistic terms, membership functions, and rules used in the fuzzy logic system. So for the simulation for 3x3 and 5x5 fuzzy rule base, it will be presented by either one, which is my group member, Shamil Bakri. So that's all from me. Thank you.
Hello, Assalamualaikum. My name is Shamil Bakri Ibrahim, and my metric card is CE190170. So today I would like to present about this assignment 2 of ICS for assignment group. So it requires us to do a design a fuzzy membership with 3x3 and 5x5. So as you can see here, this already shown for us to create the fuzzy logic controller here with the fuzzy post 2 and fuzzy post 5 into the MATLAB software. So I already have the MATLAB here. So I have done for the assignment. So I'm going to show you. So I will drag here. Okay. And then it will appear for the Simulink. Okay. So I continue to the command line first. So we type fuzzy. Okay, wait a minute. It loading to appear the designer and title. Okay. So file, import from file. So we'll be using the fuzzy post 2 firstly. And then we open it. So it will export to workspace. Fuzzy post 2 we need to copy. Okay. So this one for the fuzzy logic controller. So we need to set the fuzzy post 2 that we have copied just now from the fuzzy. Then OK. Then we need to run. The running time takes time for a while to compiling. And then I will show you for the plot graph for the X3 output position. So it will take some time for me to show it, the output. I'll wait for a while, okay. The time running for the program to run until we can plot the graph. So it will gonna wait until 100%, okay. And then I show it to you to the command window that I have done. And then I will compare with the plotting graph between X3 and X5 for the output position. So basically we have two fuzzy logic controller, which is same circuit, just different output. Just the FIS file we need to create before we need to run So we have the different value for the S3 and S5. Okay. It will take some time, so I will wait for a while. Okay. So this is a fuzzy post tool. This is a designer title. Okay. And then we need to plot the graph. So basically we have two plotting for the S5 and S3. Okay, so we're done. Okay, I will copy it. This is only I put it on Note, so easy for me to put it on the common window. So I set it for S3, then okay. So this is the graph for the post 2, fuzzy post 2. Okay, so this is the graph. So as you can see here, which is fuzzy for the blue, and this one is the red. Let me show you. So this is the output, and then this is the graph. Okay, okay. So for this for the second one, I will show it to you for the x5, 5 times 5. Okay, fuzzy file, import from file, fuzzy post 5, then export to workspace. Fuzzy post 5, copy it, then okay. Okay, then for the output position, we need to change x5. Okay, and the fuzzy post 5 that we have copied just now. Okay, and then same step, we just run, and then we put the command window for the plotting graph for the x5, and then we need to differentiate between fuzzy post 2 and fuzzy post 5 that we had set up in the fizz file from the fuzzy, and it will show us the two different plotting graph between x3 and x5. So as usual, we need to wait until 100% to finish the running program. Then I will show it to you for the plotting graph. So plot TX blue. This window is already been given for us in the video presentation that set up from our lecture. So it's just us to create a new window to put it up on our MATLAB for our assignment. So it takes some time as usual. So as you can see, this is the times 3 plotting graph, and the plotting graph for S5. We need to wait for this simulating program to finish the running. Okay, so take some time. Okay, it's already getting done. 100%. It's just the same step as a fuzzy post to just we need to put the fuzzy here. Okay, it's getting done. So you put the click sounds. So we just copy the same thing for the plot. So we just change x5, then we enter. S5 and S3. Okay, so I don't know why it doesn't appear, but it should be appear here. So yeah, that's all for my part for this presentation. That's all for my part for this presentation video. So thank you and assalamualaikum.